Question 1. Given the circumstances, what is the most appropriate action for Mr. Rivero, a senior technician inspecting a high-rise office's ventilation system, when he finds consistently low airflow readings at multiple diffusers on the top 2 floors, even though the fan appears to be operating normally and static pressure readings at the AHU are within range? A. Recommend replacing the fan motor to increase airflow capacity. B. Increase fan speed settings at the VFD control panel. C. Investigate for improperly balanced dampers or blocked ducts. D. Clean or replace the diffusers showing low flow. Answer. Correct answer. C. Explanation. Low airflow at the farthest points with normal AHU. Static pressure suggests duct design imbalance or obstructions rather than equipment failure. ASHRAE 111 and IMC Section 603 support checking damper positions and duct obstructions before altering fan settings. Replacing or modifying fan components without diagnosing downstream restrictions can exacerbate pressure imbalances and violate design intent. Question 2. The underlying principle of ventilation duct sizing involves which of the following fundamental considerations? A. Selecting the largest available duct size to minimize noise. B. Matching duct velocity to the fan motor RPM. C. Balancing static pressure losses and acceptable airflow velocity. D. Maximizing velocity to increase energy efficiency. Answer. Correct answer. C. Explanation. Proper duct sizing ensures balanced airflow with minimal pressure loss. Oversizing can cause low velocities and poor mixing. Undersizing increases noise and resistance. The ASHRAE Fundamentals Handbook emphasizes duct design must consider friction loss, velocity constraints, typically 500, 900 FPM for supply and pressure balancing. IMC 600 3.2 also reinforces energy efficiency through calculated sizing rather than overbuilding. Question 3. To better understand proper filtration strategies in healthcare facilities, Mr. Chen is evaluating a lab's ventilation upgrade. The lab handles airborne pathogens and sensitive testing materials. What filter configuration would best meet applicable standards? A. Use MERV 8 pre-filter and MERV 13 final filter. B. Use 2 MERV 11 filters in series. C. Install HEPA filter downstream of MERV 8 pre-filter. D. Use washable aluminum mesh filter for easy maintenance. Answer. Correct answer. C. Explanation. Healthcare environments, especially laboratories, demand high-efficiency filtration. ASHRAE 170 and CDC guidelines require HEPA filters 99.97% efficiency at 0.3 microns in critical spaces. Pre-filtration with MERV 8 reduces particulate load, extending HEPA lifespan. MERV 11 or MERV 13 alone don't offer sufficient protection. Washable filters do not meet code for high-risk areas. Question 4. When faced with excessive vibration and noise complaints in a mechanical room containing a centrifugal fan, which of the following should be investigated first? A. Increase fan speed to smooth vibration harmonics. B. Tighten all duct connections and damper frames. C. Evaluate fan mounting and alignment for imbalance. D. Apply acoustic liners throughout the duct system. Answer. Correct answer. C. Explanation. Vibration is often caused by misalignment, imbalanced, or bearing failure. ASHRAE Applications Handbook recommends vibration isolators and proper shaft alignment to prevent transmission of mechanical energy. Acoustic liners address airborne noise, but not vibration. Adjusting speed without fixing root imbalance risks structural fatigue and is unsafe. Question 5. The contemporary view of residential ventilation systems emphasizes which approach when balancing energy efficiency and indoor air quality, i.e., sealing all natural air leakage paths to prevent infiltration. B. Relying solely on operable windows to meet ventilation needs. C. Integrating balanced mechanical ventilation with energy recovery. D. Running exhaust fans continuously to ensure air changes. Answer. Correct answer. C. Explanation. Modern codes, ASHRAE 62.2, 2022, recommend balanced mechanical systems with ERVO ITVS to meet IEC needs while conserving energy. Sealing leakage is necessary, but passive ventilation alone is inadequate. Exhaust only creates negative pressure and backdraft risk. Continuous fan operation wastes energy if not demand controlled. Question 6. Through careful analysis of ventilation schematics, Mr. Ahmed notes that a large office space has a combination of return grills and transfer grills. If negative pressure is consistently measured in private offices, what design flaw is most likely present? A. Oversized transfer grills are allowing supply air to bypass return. B. Supply ducts are routed improperly through return pathways. C. Return paths are insufficient or obstructed, trapping air in offices. D. The valve boxes are not reducing airflow during unoccupied hours. Answer. Correct answer. C. Explanation. Negative pressure in offices often results from inadequate return paths, causing imbalance and door slam effects. The HRConquer 62.1 requires sufficient return airflow and prohibits blocking return air pathways. Transfer grills is sometimes used but must be sized correctly. VAV settings matter for efficiency but don't cause persistent pressure differentials. Question 7. Contrary to popular belief, increasing duct size in an existing commercial building does not always solve airflow issues. Which scenario best illustrates this misconception? A. Larger ducts reduce friction loss, increasing efficiency. B. Oversized ducts can disrupt balancing and cause low outlet velocity. C. Larger ducts eliminate the need for terminal dampers. D. Increasing duct size guarantees code compliance. Answer. Correct answer. B. Explanation. While larger ducts reduce friction loss, they also reduce velocity, risking poor airflow, stratification, and difficult balancing. An ASHRAE design guidance notes that duct design must consider both friction and velocity pressures. Code compliance, e.g. IMC Table 403311, depends on actual airflow delivery, not duct size alone. Question 8. The effectiveness of a variable air volume VAV system in a multi-zone retail center can be compromised if which of the following occurs during commissioning. A. Supply air temperature is too low for peak cooling. B. Return dampers remain fully open during occupancy. C. Static pressure sensors are not calibrated properly. D. All VAV boxes are set to a maximum flow rate. Answer. Correct answer. C. Explanation. Incorrectly calibrated static pressure sensors cause fan speed modulation errors, leading to under or oversupply. ASHRAE Guideline 1.1 stresses proper sensor placement and calibration during commissioning. Return damper positions and set points matter, but don't cripple the whole system the way faulty pressure control loop does. Question 9. Demonstrated by airflow monitoring in an industrial paint booth, what condition would most compromise both code compliance and worker safety? A. Excessive positive pressure in the booth. B. Use of a HEPA filter downstream of the exhaust. C. Insufficient exhaust CFM compared to PFM. D. Balanced supply and exhaust airflow rates. Answer. Correct answer. C. Explanation. Industrial paint booths must operate under negative pressure to contain fumes and ensure safety. NFPA 33 and OSHA 1910 require minimum exhaust to supply airflow ratios to prevent leakage. Positive pressure or equal balance can lead to contaminant spread. HEPA filters on exhaust are not the issue. They may even be required in some cases. Question 10. In light of recent developments, what tool should Isa Delgado use to verify terminal diffuser performance in a newly installed office ventilation system to ensure design airflow is achieved? A. Manometer to measure duct static pressure. B. Infrared camera to check thermal comfort. C. Bolometer to measure delivered air volume. D. Psychrometer to measure air dew point. Answer. Correct answer. C. Explanation. A bolometer measures air volume directly at grills and diffusers, allowing comparison with design CFM. ASHRAE 111 specifies its use during tab testing, adjusting, and balancing. Anemometers and psychrometers help with diagnostics, but not airflow quantity verification. Thermal imaging checks distribution, not quantity. Question 11. While examining a newly installed rooftop axial fan system for a warehouse, Patel notices the fan struggles to maintain the required airflow despite the motor running at full speed and no visible obstructions. What is the most plausible cause of this issue? A. Incorrect fan rotation direction reducing airflow efficiency. B. The fan blades are oversized for the system's static pressure. C. The ductwork downstream is oversized, causing back pressure. D. The motor is likely operating at lower voltage than rated. Answer. Correct answer. A. Explanation. Axial fans require correct rotation to generate proper airflow. If rotation is reversed, the fan pushes air inefficiently or even pulls it, reducing performance. IMC 603.6 and manufacturer specs mandate verifying rotation during startup. Oversized blades or ductwork do not usually cause fan failure to maintain airflow, while voltage issues typically reduce motor speed but not cause airflow reversal. Question 12. According to recent studies, when designing a commercial kitchen ventilation system, which factor most critically impacts the exhaust hood's effectiveness in capturing contaminants? A. Installing high-efficiency particulate air HEPA filters at the exhaust outlet. B. Maintaining minimum capture velocity across the hood face. C. Using centrifugal fans rather than axial fans for exhaust. D. Ensuring the hood is made of stainless steel for durability. Answer. Correct answer. B. Explanation. Capture velocity. The airspeed at the hood face is the key design factor to ensure contaminants are captured before escaping. ASHRAE 154 and NFPA 96 require specific capture velocities based on cooking appliance type and hood design. Filters and fan type are secondary. Stainless steel ensures durability but does not affect capture effectiveness. Question 13. From the perspective of indoor air quality, IAC Mr. Thompson is tasked with retrofitting an aging office building's ventilation system. He must ensure compliance with ASHRAE 62.1, which ventilation strategy best balances code compliance and energy efficiency. A. Increase outdoor air intake to 200% of the minimum requirement to ensure safety. B. Install demand-controlled ventilation (DCV) with co-sensors in occupied zones. C. Eliminate recirculated air entirely to avoid contamination risks. D. Use exhaust-only ventilation systems with natural makeup air. Answer. Correct answer. B. Explanation. ASHRAE 62.1 permit DCV to reduce outdoor air intake during low occupancy, optimizing energy use without sacrificing IAC over ventilation wastes energy, while eliminating recirculation or exhaust-only systems may cause pressure imbalances or inadequate ventilation. DCV balances fresh air needs intelligently. Question 14. While troubleshooting a constant volume ventilation system, Lopez finds that the airflow fluctuates unexpectedly throughout the day despite no changes in fan speed. Which cause is most consistent with this symptom? A. A failing static pressure sensor causing intermittent fan speed adjustments. B. Improperly set manual dampers opening and closing randomly. C. Variable air volume (VAV). Boxes are modulating airflow unexpectedly. D. Fluctuations in outdoor wind pressure affecting system balance. Answer. Correct answer. D. Explanation. Outdoor wind pressure and building stack effect can cause pressure swings affecting constant volume systems if building envelope and ductwork are not properly sealed or balanced. In 403.4. This leads to airflow fluctuations independent of fan speed. Sensor failure or VAV modulation would affect fan or box behavior differently. Manual dampers don't move randomly without external cause. Question 15. With respect to safety protocols, what is the best immediate action when Mr. Daniels encounters sparking and unusual heat near the electrical motor connection of a ventilation fan during startup? A. Continue running the system while monitoring temperature. B. Shut down power immediately and report for electrical inspection. C. Tighten electrical connections while the motor is running. D. Replace the motor with a higher horsepower unit. Answer. Correct answer. B. Explanation. Sparking and overheating are clear indicators of an electrical fault risking fire or equipment damage. OSHA and NFPA 7i require immediate shutdown and lockout procedures before attempting repairs. Continuing operation or adjusting connections under power is hazardous. Replacing with a larger motor without diagnosing the fault is improper. Question 16. Considering the evidence from pressure testing, a commercial building shows positive pressurization relative to the outside. How might this affect ventilation system operation and indoor air quality? A. It would improve IAC by preventing infiltration of outdoor pollutants. B. It can lead to increased energy costs due to uncontrolled leakage. C. It creates negative pressure zones in interior rooms. D. It guarantees compliance with IMC ventilation requirements. Answer. Correct answer, B. Explanation. Positive building pressurization can cause uncontrolled air leakage through the envelope, increasing HVAC load and energy consumption. HRConquer fundamentals. It does not inherently improve air as it may drive moisture and pollutants into unintended spaces. Negative pressure zones are the opposite effect. Code compliance requires balanced ventilation, not just pressurization. Question 17. Taking into account psychrometric principles, what is the effect on latent heat load in a space if ventilation air is supplied at higher humidity levels than the design intent? A. Latent load decreases due to reduced moisture transfer. B. Latent load increases, requiring more dehumidification capacity. C. Sensible load compensates, keeping total load constant. D. There is no effect on latent load since temperature remains constant. Answer. Correct answer, B. Explanation. High humidity ventilation air adds moisture, increasing latent heat load, which requires additional energy for dehumidification. HRConquer Handbook. Fundamentals. Sensible load relates to temperature changes, not moisture. Ignoring latent load effects can cause discomfort and mold risks. Question 18. Among the various damper types, HRConquer must select one for fire-rated ductwork to maintain ventilation during normal operation, but seal in case of fire. Which damper type best suits this application? A. Manual volume damper. B. Motorized control damper. C. Fire smoke damper. D. Backdraft damper. Answer. Correct answer, C. Explanation. Fire smoke dampers comply with NFPA 90 and IMC 607, designed to close automatically upon fire detection to prevent smoke and flame spread while remaining open for airflow under normal conditions. Manual or motorized dampers lack fire rating. Backdraft dampers prevent airflow reversal but are not fire rated. Question 19. During the commissioning of a multi-story office ventilation system, Ms. Huang finds unusually high static pressure in the ductwork. Which action should she prioritize to address this problem effectively? A. Increase fan speed to overcome pressure loss. B. Identify incorrect duct restrictions or sharp bends. C. Reduce supply airflow to reduce pressure. D. Install additional sound attenuators to balance system noise. Answer. Correct answer, B. Explanation. High static pressure usually indicates duct restrictions such as undersized ducts, sharp bends, or blockages. HRConquer Fundamentals emphasizes identifying and rectifying physical causes before increasing fan speed, which wastes energy and may damage equipment. Sound attenuators affect noise, not pressure. Question 20. Within the framework of ventilation standards, why is it critical for a ventilation technician to understand the difference between static pressure and velocity pressure when performing system balancing? A. Static pressure reflects fan motor efficiency, velocity pressure reflects airflow temperature. B. Only velocity pressure affects duct sizing. Static pressure is negligible. C. Static pressure represents resistance in the system, velocity pressure represents kinetic energy of airflow. D. Both static and velocity pressures are interchangeable and have no distinct roles. Answer. Correct answer, C. Explanation. Static pressure is the resistance the fan must overcome duct friction fittings, while velocity pressure is the dynamic pressure due to airflow speed. Correct balancing requires measuring and understanding both pressures per HRConquer 111. Misinterpreting these can cause improper fan selection, duct sizing, and system inefficiency. Question 21. When considering the evidence from a retrofit ventilation project in a mixed-use building, Mr. Wilson discovers that the existing centrifugal fan is delivering less than the required airflow despite no apparent mechanical issues. What should be his primary diagnostic focus? A. Verify duct leakage and sealing quality along the distribution system. B. Immediately increase the fan motor horsepower rating. C. Replace the fan with an axial fan to improve performance. D. Remove fields to reduce pressure drop. Answer. Correct answer, A. Explanation. Duct leakage causes significant loss in delivered airflow and reduces system efficiency. Inc. Section 603.7 requires proper duct sealing to prevent air loss, increasing motor size or changing fan type without addressing leakage wastes energy and money. Removing filters compromises HRConquer code compliance. Question 22. From a practical standpoint, HRConquer needs to ensure a valve system maintains proper static pressure set points during varying building loads. Which control strategy is most effective? A. Fixed fan speed operation with manual dampers. B. Static pressure sensor feedback controlling variable fan speed. C. Constant volume operation with supply dampers modulating. D. Manually adjusting fan speed daily based on occupancy. Answer. Correct answer, B. Explanation. Valve systems optimize energy use by modulating fan speed to maintain static pressure set points as described in ASHRAE Guideline 36. Fixed speed or manual adjustments lack responsiveness and efficiency. Constant volume systems waste energy by delivering excess airflow when demand is low. Question 23. Under the assumption that a ventilation system uses natural ventilation exclusively, what is a major limitation that Mr. Fernandez should consider when designing for occupant comfort in a densely occupied commercial office? A. Inability to control indoor humidity levels. B. Excessively high system installation costs. C. Over-reliance on motorized dampers for airflow control. D. Too high static pressure losses in ductwork. Answer. Correct answer, A. Explanation. Natural ventilation depends on environmental conditions often failing to control indoor humidity and temperature adequately, especially in humid or extreme climates. Mechanical ventilation with humidity control is preferred for occupant comfort per ASHRAE 62.1. Natural ventilation generally has lower installation costs and no motorized dampers or duct losses. Question 24. The primary reason for including a fire smoke damper in a ventilation duct penetrating a fire-rated wall is to A. Reduce sound transmission between compartments. B. Maintain balanced airflow under normal operation. C. Prevent the spread of fire and smoke during an emergency. D. Improve overall system energy efficiency. Answer. Correct answer, C. Explanation. Fire smoke dampers are required by INC 607 and INEPA 90 to automatically close during fire to maintain compartmentation and prevent smoke migration. Sound transmission and energy efficiency are secondary considerations. Balanced airflow is maintained through normal damper operation but is not the primary reason for fire dampers. Question 25. Based on the information from an airflow assessment, HRConquer observes that the velocity pressure readings in a supply duct are significantly higher than static pressure. What does this indicate about the airflow conditions? A. High airflow velocity relative to system resistance. B. Excessive duct leakage causing pressure drop. C. Blockage causing back pressure in the duct. D. Imbalance due to closed dampers downstream. Answer. Correct answer, A. Explanation. Velocity pressure correlates with kinetic energy from air velocity, so high velocity pressure compared to static pressure means the airflow speed is high relative to system resistance. Duct leakage and blockage primarily affect static pressure. Closed dampers reduce velocity, not increase it. Question 26. Considering the implications of psychrometric chart readings, Mr. O'Neill adjusts the supply air temperature but observes increased condensation on duct surfaces. What is the likely cause? A. Supply air temperature is too high, increasing relative humidity. B. Supply air temperature is below the dew point of surrounding air. C. Supply air velocity is too high, causing condensation. D. Supply air is too dry, leading to condensation. Answer. Correct answer, B. Explanation. Condensation forms when duct surface temperature falls below the dew point temperature of ambient air. Lowering supply air temperature without controlling humidity can cause condensation and mold growth. High velocity or dryness does not directly cause condensation. Question 27. In a context of industrial ventilation systems, which factor most influences the selection between axial and centrifugal fans? A. Noise generation in the occupied zone. B. The required total pressure against system resistance. C. The availability of motor sizes. D. Aesthetic integration with building design. Answer. Correct answer. B. Explanation. Axial fans are best suited for low static pressure and high airflow, while centrifugal fans handle higher static pressure systems better. ASHRAE Handbook. HVAC systems, noise and aesthetics are secondary. Motor availability is rarely the limiting factor. Question 20. What factors contribute to the failure of manual balancing dampers in large ventilation systems? A. Manual dampers provide too precise control, leading to system instability. B. Manual dampers are prone to being improperly set or adjusted over time. C. Manual dampers increase static pressure excessively, causing motor burnout. D. Manual dampers are not compatible with ductwork materials. Answer. Correct answer. B. Explanation. Manual dampers often become improperly adjusted or stuck due to lack of maintenance, leading to airflow imbalance and inefficiency. ASHRAE 111. They do not inherently cause instability or motor burnout, and compatibility is not an issue. Question 29. When faced with inadequate ventilation in a large conference room, what is the best immediate step HRConquer should take to diagnose the problem? A. Increase the supply air temperature to improve airflow. B. Measure supply and return airflow volumes at diffusers and returns. C. Replace all duct insulation to reduce pressure drop. D. Increase fan motor speed beyond design limits. Answer. Correct answer. B. Explanation. Measuring actual airflow with a bolometer or an anemometer identifies whether ventilation rates meet design criteria. A critical first diagnostic step. ASHRAE 111. Temperature adjustments, insulation replacement, or increasing fan speed without airflow data risk system damage and inefficiency. Question 30. Throughout the course of commissioning a ventilation system, why is it essential to calibrate manometers and other airflow measuring instruments regularly? A. To ensure readings are comparable across different systems. B. Because manometers are prone to breakage without calibration. C. To maintain measurement accuracy necessary for proper balancing and compliance. D. To increase the lifespan of the equipment. Answer. Correct answer. C. Explanation. Calibration ensures measurement accuracy essential for correct system balancing, energy efficiency, and compliance with standards like ASHRAE 111 and IMC 604. Without accurate data, balancing can lead to underperformance or code violations. While equipment longevity is important, calibration primarily affects data reliability.